Hi everyone, I hope you enjoyed the last video that we had about electrolysis of lead bromide. Today we are going to see something about the electrolysis of acidified water. Oh, water we have seen, but why should it be acidified? And what is the acid that we are going to add? And what is the reason for adding it? That's what we are going to see in this electrolysis. Here we go. So we go into this. First thing that we have is the electrolytic cell. And doesn't this look different compared to all other electrolysis apparatus? This is different, and this voltmeter is also called as Hofmann's voltmeter. Okay, now going into it, there are three arms in this voltmeter as you see, and the center arm is the one through which we add the electrolyte. So what is the electrolyte made of? The electrolyte is made of pure distilled water and dilute sulfuric acid. Now, why do we need to add dilute sulfuric acid? Because pure distilled water has only molecules. We saw in the previous video that if it contains only molecules, then it is a non-electrolyte. So it cannot obviously conduct electrolysis if it has only molecules. Therefore, we add dilute sulfuric acid to it so that this increases the conductivity. Not only increases, it helps in breaking down this distilled water into ions. So it breaks down into ions in the presence of dilute sulfuric acid. Okay, then the next question comes, why not dilute nitric acid or dilute hydrochloric acid? That's the next question. These two are volatile, which means they will evaporate faster, they will react faster, they will interfere with the reaction. So they break down into nitrate ion or chloride ion in this case, and they tend to interfere with the electrolytic process. So we can't add dilute nitric acid or dilute hydrochloric acid, but we add only dilute sulfuric acid. Okay, so that means let us see the dissociation reactions. How does it break down? So what are we going to have? We are having water. This dissociates into H plus and OH minus. Dilute sulfuric acid. This dissociates into 2H plus and sulfate ion, SO4 2 minus. So these are the things that are happening. Now let's go on to the reactions at cathode and anode. So it has already broken down. Now it has to move towards the respective cathode and anode. Actually, in this electrolysis, what is actually happening is you are breaking down molecules of water. Into what is it broken down? Actually into hydrogen and oxygen. So this is the product. These are the products of breaking down water molecule. So when we balance it, it goes this way. So this is the reaction that's actually happening. Alright, now coming to the reactions at cathode. What are the cations that are there? Only hydrogen is there. Okay, so hydrogen migrates to cathode. Why does it migrate to cathode? Because cathode is negatively charged and hydrogen is positive. So opposite charges go towards each other. Alright, so hydrogen migrates to cathode and there it has to become neutral atom. How does it become neutral atom? This hydrogen ion has only one proton. So it needs an electron. So to become neutral, it has to add one electron or gain one electron to give hydrogen neutral atom. And does it exist like this? No, it doesn't exist as a single hydrogen atom. And it's always diatomic, which means two atoms make one molecule. But here we see in this reaction that there are 4 hydrogen atoms which are formed as product. So what we can do, we can multiply this by 4 to give you 2H2. So this is what will be the result at the cathode. Okay, next we go to reactions at the anode. Alright, when we come to this anode part, which are the ions? Negatively charged anions, there are 2 of them, hydroxyl ion and sulfate ion, both will migrate to anode. You know, it is like a running race where all participants are running in the same direction. These 2 radicals also will be traveling towards the anode, but there is a preferential discharge or selective discharge, according to which OH being lower in the electrochemical series, OH ions or radicals will be discharged. Why? Because they are lower in the electrochemical series. Alright, so the preference goes to the hydroxyl ions. So after that, what happens to this hydroxyl ion? It should become neutral atoms. And we don't have a hydroxyl neutral atom at all. But instead, you see here, there are 2 water molecules and an oxygen molecule that is formed. So OH has to lose one electron to give hydroxyl ion. And when we multiply this by 4, that means 4 electrons are gained here. 4 electrons should be lost here too. Therefore, multiply this also by 4, which results in 2H2O plus O2. So you have got everything here about this equation. You have hydrogen here, water is present and oxygen is also formed. Alright, so now we move on to the products of this electrolysis. So what happens is, as we add this dilute sulfuric acid to this pure distilled water, because it is a non-electrolyte, it becomes an electrolyte, breaks down, and these are the products that are formed. Slowly as the time goes by, say after about 40 minutes or 30 minutes, slowly you can see bubbles rising up in the 2 arms of this Hofmann's voltameter. As it goes by the end of 3 to 4 hours, you can see that this has become double the volume of this side. Okay, so the anode side has a volume of 1, then that means here it would be 2 volumes on the cathode side. Okay, so that is the product. So we move on to the products at the cathode and anode. So what do we observe? At the cathode, we have 2 volumes of hydrogen. How do we know? It's all gas and it has no color, no smell. How do we know about it? This hydrogen burns with a pop sound, so that goes to prove that it is hydrogen. Okay. Similarly, at anode, what is the product formed is 1 volume of oxygen. Again, how do you find out? Both are gases, there is no color. We can find out by taking a glowing splinter, introducing it at the tip. It glows brightly and fast. Then we know that the gas evolved is oxygen. So what happens is, what we see in this voltmeter is that the products are in the ratio 2:1, that is 2 volumes of hydrogen and 1 volume of oxygen. This is all about the electrolysis of acidified water. Electrolysis of water is an example of catalysis. How do you say that? What is a catalyst? A catalyst is one which will alter the rate of the reaction without undergoing any change in mass. Okay. Now, if we take this dilute sulfuric acid, it is being added, and without that the electrolysis does not happen, but by the end of the electrolysis it's the same amount as it was in the beginning. So, the amount of dilute sulfuric acid remains the same, but this is responsible for the electrolysis. Okay. So, that means it catalyzes this reaction. Therefore, this is an example of catalysis. It helps water molecules to break down. That means it is helping it, but it is not taking part, and the amount remains the same. So, it is an example of catalysis. So, with that we finish this electrolysis of water, and I hope we will keep watching for the next electrolysis, which is going to be aqueous copper sulfate.